In this video, I will explain about the full wave rectifier circuits. First, let's have a look on how the circuits look like. So basically, this is how the full wave rectifier circuits looks like. A full wave rectifier circuit consists of components such as a AC power supplies, a bridge rectifiers, two resistors, a capacitor, and a Zener diode. A bridge rectifier consists of four diodes used to ensure the current can flow in forward and reverse bias. And a capacitor is used as a filter to smooth out the pulsation and produce a more stable DC voltage output, while a Zener diode acts as a voltage regulator to regulate the output voltage of a power supply so that it remains constant as the input voltage fluctuates or the load varies. After we get to know all the components in the full wave rectifier circuits, now let's look at how the current flow in the full wave rectifier circuits. So for forward bias, from the positive terminal, the current flow following the red arrow and pass through the first diodes and then go to the first resistor R1 and capacitor C1, then passing through the resistor R2 and go to the Zener diode as I mentioned just now. The Zener diode acts as a regulator to regulate the output voltage remain constant and keep going to the second diodes and then go back to the negative terminal. For reverse bias, the current flow from the negative terminal following the blue arrow and pass through the diodes and following the routes like how the forward bias current flow passing through the resistor R1 and capacitor C1, then pass through the resistor R2 and Zener diode D2. After that, go back to the diode and back to the positive terminal. After we know how the current flow, now let's look at the waveform of the voltage. The first oscilloscope shows the waveform of a AC power supply which is a sine waveform, and the second one is showing the pulsating DC waveform which is the waveform after the bridge rectifier, and the third one is the ripple waveform which is the voltage after the capacitor, and the last one is after the Zener diode is added, it shows a regulated DC waveform. The sine wave show is the voltage of a AC power supply, while the pulsating DC waveform show is due to the bridge rectifiers convert the AC power supply to DC outputs. Next, the ripple waveform shown is because of the capacitor due to the charging and discharging of the capacitor as it attempts to smooth out the pulsating DC waveform. Last, the regulated DC voltage waveform, which is a steady and constant voltage level without a significant ripple, but not this due to this is a practical model and may not able to eliminate all ripples because of factors such as temperature changes. That's all my explanation about the full wave rectifier circuits. Thank you for your attention watching this video.